Mars wasn't always a frozen wasteland. Billions of years ago, rivers carved its surface, lakes shimmered under a thick atmosphere. But something happened, something that stripped the planet bare, turned oceans into dust, and left only traces of what used to be. Today, scientists think they finally understand why. When NASA's orbiters first mapped the surface of Mars in detail, the images told a story no one expected. Deep channels cut across the landscape, not the marks of wind or lava, but of flowing water, winding riverbeds, and the outlines of what once were lakes and even oceans spread across the planet's northern plains. Later missions confirmed what the pictures hinted at. Rovers like Curiosity and Perseverance found minerals that can only form in the presence of liquid. They were signs of a climate that lasted millions of years. Mars at that time would have looked familiar. Blue skies tinted red with dust, clouds drifting above calm lakes. It wasn't Earth, but it wasn't the frozen desert we see today either. Now, the way this all disappeared didn't just happen overnight. You see, Mars began to change, gradually, almost imperceptibly at first. Its atmosphere, once thick enough to support clouds and weather, started leaking into space. Mars is only half the diameter of Earth, and that means its core cooled much faster. Over time, that cooling shut down the global magnetic field, the invisible shield that protects a planet from the solar wind. When that protection faded, the sun's charged particles began stripping the air away, atom by atom. Hydrogen from water vapor escaped first, followed by oxygen and carbon dioxide. Without a dense atmosphere to trap heat, the planet's surface froze, and the remaining water retreated underground or into the polar ice caps. NASA's MAVEN spacecraft later confirmed what had long been suspected. Mars is still losing its atmosphere today. Even now, the solar wind continues to sweep particles off into space, a faint reminder of how the planet's transformation never truly ended. What's left of that ancient world hasn't completely vanished. Across the planet, you can still see the traces of what it used to be. Long winding channels stretching for thousands of kilometers, carved by rivers that haven't flowed in billions of years. The air today is so thin that liquid water can't survive. If it ever appears on the surface, even for a moment, it either boils away or freezes solid. The atmosphere simply can't protect it anymore. Every so often, dust storms rise from the surface, enormous walls of fine red sand that can engulf the entire planet. Some last for weeks, others for months, blocking sunlight and covering everything in shadow. But the thing is, not all of Mars is lifeless. Orbiters have revealed layers of ice buried under dust and rock stretching farther than scientists once imagined. Near the poles, carbon dioxide freezes and thaws with the seasons, expanding and shrinking the ice caps, like the planet is still breathing in slow motion. And there are even hints of something more. In certain slopes, dark streaks appear during warmer months, fading when temperatures drop, signs that salty water might still trickle just below the surface, hidden from the harsh sunlight. It's fragile, but proof that Mars hasn't completely stopped changing. Even now, Mars is still changing, just too slowly for us to see with the naked eye. NASA's MAVEN spacecraft, orbiting the planet since 2014, has been watching how the atmosphere continues to escape into space. It found that when solar storms hit, the process accelerates. The charged particles from the sun collide with the upper layers of air, knocking atoms free and flinging them away at incredible speed. That constant erosion has transformed Mars from a world with clouds and rainfall into one with skies so thin they barely scatter sunlight. You can almost think of it as a planet in reverse, where weather doesn't build up an atmosphere but slowly erases it. What's remarkable is how much we can still learn from these traces. MAVEN detected oxygen and hydrogen escaping right now, the same elements that once formed its oceans. And it's not just air that's vanishing. When the atmosphere thins, it can no longer hold warmth. The surface cools, and the little moisture left in the soil freezes deeper underground. Mars starts to lock more and more of its water away, buried beneath layers of dust and ice. So when we look at Mars today, we're watching the final stages of a slow process that's still unfolding. But the story of Mars isn't finished yet. Right now, multiple spacecraft are still orbiting and roving across its surface, each one adding another piece to the puzzle of where that water went. The European Space Agency's ExoMars Trace Gas Orbiter has been searching for faint traces of methane, a gas that on Earth can come from geological activity or even from living organisms. NASA's Perseverance rover is drilling into ancient lake beds, collecting rock samples that will one day be sent back to Earth. Those samples could reveal whether Mars ever hosted microbial life, back when it still had oceans and a thick atmosphere. In 2018, scientists using radar on the Mars Express orbiter detected what looked like a subsurface lake beneath the southern ice cap, a potential pocket of salty, liquid water. Later, Curiosity found complex organic molecules preserved in ancient rocks, along with seasonal spikes in methane levels that rise and fall throughout the Martian year. None of it proves life has ever existed there, but each discovery pushes the line between unlikely and maybe a little closer. It's as if Mars keeps leaving clues behind, just enough to make scientists keep searching. That's what makes the next decade so important. New missions from NASA, the European Space Agency, and even private companies are being designed to return to Mars, to bring back those rock cores, to drill deeper than ever before, and to finally answer the question that's haunted every mission so far. Did Mars really die? Or is it still holding on beneath the dust?